Hello everyone and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY, and today we're going to be going over how to troubleshoot a step-down transformer. Thank you to everyone tuning in to Jumperman Tech. Today we're going to be going over how to troubleshoot a step-down transformer. If you find this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week, and let's get straight into it. Before we can begin troubleshooting, it's important to understand what is a step-down transformer and how it actually works. Essentially, a step-down transformer is an electrical component that steps down the voltage. So your transformer consists of two coils, a primary coil and a secondary coil. Your primary coil is always going to have the higher rated voltage, and then we step down the voltage to our secondary coil, which is going to be lower. In this case, this transformer can either be 120, 208, or 240 volts as your incoming power as your primary coil, and then it steps it down to 24 volts. Some of the best advice that I can give is pay attention to detail. Your attention to detail, not only as a technician, but in life, will take you very far. So let's see what's going on here. We see some bold lettering here. That's going to be our model number. Underneath it says CAT number. I believe that's catalog number. And again, it's referencing this model number. We have a primary and secondary. Let's go into detail here. So your primary coil is going to have a common, which is your white color. And then we have three other voltages with three other colors. So 120 is going to represent the black wire, 208 volts is going to represent the red wire, and 240 volts is going to represent the orange wire. So depending on what the incoming voltage is, that's what you're going to see connected. In this case, we have 120 volts. So white and black is going to be connected here. If we had 208 volts, you're going to notice the white and red is connected. If we had 240 volts, we're going to notice the white and the orange is connected. From there, we have a secondary coil where we're going to step down the voltage from either 120 to 24, 208 to 24, or 240 to 24. So your secondary is red and green. All right? So those are the colors of our wires. Those cannot be changed. It is what it is. It says 40 VA, 40 volt amps. This is a Class B insulated transformer. Then it says it's a Class 2 transformer. Then we have some lettering here, not exactly important. What's important is understanding your primary voltage and your secondary voltage, and colors are important in this case. This is an electrical training board that I designed and created, and what we're actually looking at is an air conditioner. The way we're going to troubleshoot this transformer is by first identifying what we're working with. If there's a label, definitely pay attention. Read what you can. A lot of times you're not going to be able to read what you can. So a good way to find out what is your primary voltage, look at the voltage of the system you're working on. If this happens to be a 208 volt system, chances are 208 volts is going to be your primary voltage. If you have a 120 volt system, your 120 volts is going to be the voltage you're looking for at your primary. I'm going to start off with what's the easiest and fastest way to check if your transformer is operating. The way to check that is to make sure you have your secondary voltage. The easiest place I would say to check for that is behind your thermostat. You're going to have a constant 24 volt supply between your R and C terminal. Instead of climbing into crazy places, going into attics, running outside, and taking off all these panels, the easiest and fastest way would be to go straight for your thermostat. We're going to pop off the faceplate for our thermostat, and we're going to go between R and C with our voltage meter. When the system has all the power on, the fastest and easiest place is definitely going to be your thermostat. You don't have to run around taking off panels, climbing into who knows where, setting up ladders, and all those things. Where you have a constant 24 volt supply at your thermostat. Your C wire stands for common, and your R stands for your 24 volts, your power wire. And this is all coming directly from your transformer. So between R and C, you should have 24 volts. I have my multimeter set to volts AC, and we're simply going to check between R and C. Right there, we have 28 volts. There's no such thing as a perfect world. You're going to have a voltage close to 24 volts. This indicates that our transformer is good because we have our secondary voltage. The reason I go with this first is because if we have our secondary voltage, then we know we have the proper voltage on our primary and we have incoming power, and this saves the most time. In this case, our transformer is good. If between R and C we didn't have 24 volts, now we have to further look into what's going on. Now we need to make sure, do we have voltage at our primary before we can actually say that this transformer is bad. No matter what kind of transformer you have, you're going to have two wires connected at your primary, and you're going to have two wires connected at your secondary. Your secondary, you don't really have an option. It's going to be your red and green, and this is always going to be your 24 volts. But if you look at our primary, we notice we have a few multiple readings with a few multiple colors. This indicates to us that we could have any one of these voltages, but it's always going to be between two wires. One wire that's always going to be connected is your common, and that's going to be your white wire. So what is this actually telling us? That means between white and black, we should have 120. Between white and red, we should have 208. And between white and orange, we should have 240. So now let's trace out the wires. Okay, coming out, here I see my white, this is my common. But what do we have here? The red and the orange is capped off, so that means we're not using that. The red is 208 and the orange is 240. So now we know we're using our 120 volt circuit, because if I follow this again, here's my black wire. So between black and white, we should have 120 volts. All right, so we have our meter set to volt AC. I'll turn the power on. Between black and white, we should have 120. Right there, as you can see, we have 122 volts, indicating we have our 120. So let's say if we had any of these primary voltages and we didn't have 24 volts, then your transformer is bad. But before you say that, pay attention to your transformer. Sometimes there's a built-in breaker inside, and sometimes there is an inline fuse connected. So we have 120 volts at our primary, and then we checked at our thermostat, we had our secondary. Of course, in this case, everything is good. So here's our 120, right? We're gonna make sure that we have our primary voltage, and then we're gonna make sure we have our secondary. You can follow the wires. So it's gonna be your red and green, and I can see the red and comes here and the green comes here. This is a low voltage terminal block. So between red and the green wire, right there, we have our 28 volts. So that is a good transformer. To keep things simple, the way to check a transformer is to first identify, if you can, what is your primary voltage, see which colors they are, and make sure you have your primary voltage. Check your secondary voltage and make sure you have your secondary voltage. If you do, then of course your transformer is good. I'm going to end off this video with a couple tips. If you have your incoming voltage and you have no secondary voltage right away, your transformer is bad. But before you can make that decision, make sure that there's no reset button or little breaker, any type of switch that you see on the transformer, because if that trips, you wouldn't have a secondary voltage. A lot of times they do have this protection. In this case, we do not have one, but if you follow the wiring, we do have an inline fuse. So you would turn off the power and make sure that your fuse is actually not blown. So if you have your incoming power, you don't have a switch here that tripped, and in this case we have a fuse and the fuse is good and you still don't have 24 volts, your transformer is bad. It's all about making sure if you have your primary and secondary voltage. So if you don't have voltage at your primary, You need to stop what you're doing. It has nothing to do with the transformer. You need to look into the incoming power to the system. That means you're not getting incoming power. You got to follow those wires. So those are a couple tips, but pretty much that's what it is. Make sure you got your primary, make sure you got your secondary. If so, you have to go about things with the clues that the control circuit gives you. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week, and I'll catch you all next time.